All right. Well, good afternoon. I realise today's getting a bit long, 5 o'clock, and I think I'm standing between you and beer, so I shall carry on. So I'm Mike Mustard, Business Development Manager for company Findley, Irvine, and I look after our rail business. So Findley, Irvine, we are a Scottish manufacturing company, electronics manufacturing company based near Edinburgh, but we don't just manufacture electronics, we kind of supply whole solutions, and we're into highways, airports, we do a lot of rail solutions, and we do some Ministry of Defence systems for submarines, etc. On rail, I'm sure a lot of you are familiar with condition monitoring. The UK rail market, or the UK rail network, has invested an awful lot in condition monitoring for things like signalling, power. We're moving on to structures, track, and civil assets. And just for an example, in the UK rail network, there's about 40,000 assets being monitored live all the time across across that network. And we've supplied an awful lot of equipment to allow them to do that. But signalling's been done, power's been done, and we're now just moving on to things like structures, overhead lines, signalling gantries, bridges, tunnels, whole gambit of different kinds of things. And all of these require sensors to carry out the basic measurement. The project that we're talking about at the moment is monitoring landslides for Network Rail, which is a big issue for them. Like most rail networks, landslides cause massive disruption. And it's a big issue for the UK because until about 4 years ago, although we had landslides, we didn't have that many. And then about 4 years ago, 5 years ago, our rainfall pattern changed, and we suddenly started getting very heavy localized rainfall. And that resulted in a massive spike in the number of landslides, basically, that we were having across the network. You know, kind of like 100% increase virtually overnight. And as a result of that, an organisation called the Office of Rail Regulation in the UK, which is kind of a government body that oversees Network Rail, trying to make sure they do the right thing, insisted that Network Rail started to do something about their earthworks. Because up to that point, they were meant to send people to track if there was going to be adverse weather, and they would literally watch the embankments, or the cuttings rather, for them collapsing, which is obviously very heavy on manpower. And also, what's really been playing in their favour is that they hadn't had any serious accidents, or nobody was hurt, or seriously hurt, in all the derailments that they'd been having and continue to have. Some of the derailments are actually quite small, and you wonder why they worry about them. But you can see there's a very small amount of earth that's actually obstructing the track, and you might just see a train up there, but that's enough to derail a train. Obviously, it's not a major derailment because the train's carried on and nothing's happened particularly, but it stopped the train. And they're still happening. This is a site in Scotland in January this year, which was a fairly major mudslide and obviously derailed the train. So it's not a problem that's going away, and Network Rail had to address it. So they kind of went to the market and a tender, basically, and kind of in the spec was a system that had to be reliable, robust, solar battery powered, wireless, because they don't want to run cables anywhere just because of the cost of installing it and the maintenance costs. Had to be low cost because they want to put a lot of these systems out there. Had to be simple to install and maintenance free. Had to be simple to install because they wanted to, if you like, de-skill the teams that were installing these systems around the network, so they could harness, let's say, relatively low-skill manpower to install electronic systems. And maintenance-free, well, nothing's ever maintenance-free, but they wanted to reduce maintenance because it's the overall cost of the system they wanted to keep down. So Network Rail, they had a specification, and essentially what it is these each of these little spikes is kind of one of these things. So it's a pole that gets put on the basically hit into the ground, and we've got a tilt sensor on the top. This is the tilt sensor we designed, so it kind of knows where it is, what angle it's sitting at, and if it's very simple, if 1 or 2 or 3 of these go, Then they report wirelessly back to a solar-powered logger with a couple of cameras, and it reports the alarm with some pictures. So the logger side of it is all very straightforward. The cleverness, if you like, is in these tilt sensors. So the sensor itself, this thing sitting on the top, it's actually accelerometer based. It's 3-axis. So we are measuring in all 3 axes, all 3 degrees of rotation. And it's obviously wireless. Battery life, Network Rail's funding periods are based on 5 years. So they get money guaranteed for a 5-year time, and the next one's actually coming up next year. So we thought a minimum of a 5-year battery life was a sensible thing to aim for. And okay, the project's been going maybe 3 years now. 5 years seems perfectly achievable, and we're now sort of thinking 5 to 10 years is a better target to aim for. There's no calibration required. That goes back to the idea of simple to install. So again, they just simply pull on the ground, screw the sensor on the top. That's it. Again, no alignment required, which is, you might add, is possibly a wrong thing to do. Because we measure in 3 axes, so we know whichever way it's rotating. All Network Rail wanted to do, they wanted to know if it was moving. They didn't care if it was moving left, right, forwards, backwards. They just wanted to know it was moving. I think with hindsight, that might change, and they go back to recording in each direction as they're reporting into which each direction it's moving in, because they're losing information that could be of use to help them diagnose what's actually going on. So the logger, nothing terribly clever about the logger. Logger's a logger, we make it, etc. One of the interesting things with working on rail, trying to get nighttime images, you can't use standard IR lamps because they have a red glow, and it could be seen as a stop sign for a train. So you have to use covert IR, which unfortunately doesn't illuminate the track or the ground terribly well. And that's a daytime picture of this site, and that's a nighttime picture, so it's not brilliant. We do put reflective tape around the sensors so you can see them, and partly the idea is you can see if they have moved from the image. There's a whole world of image processing we can look at to try and extract from the image whether sensors have moved to back up the actual measurement. Because like a lot of people, as you know, if you're measuring something, it's good to have a second way of measuring that to confirm if the first measurement is correct. And it's better that as an independent way of doing it. So I think there's a whole world of image processing we can move into in time. There's a management system, obviously enough to collect and manage the data, route the alarms, etc. This is a typical site on what's called the East Coast Main Line in the UK. I don't know how well you can see it, but there's yellow poles there, each with sensors. This is an old slip site, which is maybe why it's a bit more interesting. This is quite an old slip, but they deemed it was worth fitting a system here, just in case that was to slip again. Here's the data is not very exciting. Most of the time it's dead flat, which is what you want. Sometimes it starts to move. This is just a very slight movement. The degree, what's considered significant is if this moves by 5 degrees in any axis, that's considered worth investigating. So the alarm level at the moment are set to 5 degrees, which is not a lot. So it doesn't need much movement to trigger them. So I say we're involved in the pilot project just now. There's 180 systems across the country at the moment. We've got 40 live on the East Coast Line, and the remainder are kind of being commissioned, I guess, if you like, at the moment. So when that's live, so what that means at the moment is that if 2 or more of these tilt sensors move by 5 degrees, NetRail are going to stop trains, and then they're going to investigate, which is a safe thing to do. However, there's a commercial implication in that. If in the UK, we have what's called delayed minutes. So if Network Rail stop the trains, the train operators can effectively claim money back from Network Rail, and that can very quickly turn into tens and hundreds of thousands of pounds. So it's a big decision by Network Rail that they are taking to rely on the system to stop trains if two or more of these go. At the moment, we've got 7,000 of these sensors across the network. The sensor itself, one of the reasons we won the job, as it were, the tender, was that most of the people competing were coming from geotechnical backgrounds, so they were used to measuring bridges, tunnels to like 0.001 degree type thing, whereas this application didn't need that degree of accuracy. It just needed to measure to 0.1 degree, because really at the end of the day it's an alarm bell. It's not really it does measure, but it's not really a measurement tool. A limitation, which, because we're measuring rotation, so we can see rotation in the axis, but what we can't see is a translation. So a straight movement or X or Y kind of thing, we won't see that. But you'd have to be very, very unlucky if something slipped and you got a straight translation move and not a rotation. We're also measuring every second, and we do that to eliminate things like, principally it's wind vibration, so we can filter out vibration. And we can still get 5-year battery life, at least 5-year battery life out of that. So I'll go back. One of the things we did when we developed this, we basically borrowed some technology out of phones these days. Everybody's phone these days can, when you hold it, it knows where it is. It's got compass, it's got accelerometers, it's got a lot of sophistication in the phone. And the software, although it's complicated, complex bit of maths to turn that back in, to check acceleration and turn it back into angle or rotation, it is there. I suppose from the wireless point of view, one of the things that we thought at the beginning, and this probably has changed now because this is 2 or 3 years old, but we thought mesh would be a fantastic thing to do, redundancy, sensor talking to sensor. However, 2 or 3 years ago when we were or a couple of years ago when we were proving and trialing this, we found that mesh took too much power. So we swapped to a simple star network, basically polling the sensors, each sensor. And because the sensors weren't that far apart, at the moment it was kind of a 50-meter range, polling was adequate, and it saved significant amount of power. I'm guessing, I'm not as much technical these days as I used to be. I'm guessing there's now cleverer ways to do mesh, and it's I think it's something we should look at again, because it opens up, certainly in our world of application, the ability to transmit data in a linear line over long distances is a good thing, and the redundancy it brings is a good thing. And because we're Scotland, I'm finished. That's Edinburgh Castle. I don't know if anybody's been to Edinburgh in Scotland. This is Waverley Station, the main trade station, and this is something else we're quite well known for. So thank you.